Hello everyone, welcome to my chemistry channel B.L DASH Short and Sweet in Chemistry. Also, I want to welcome to the topic Lewis and resonance structure with formal charge. And this is part 5. This is part 5 where the molecule is nitrous oxide. The formula of nitrous oxide, that is N2O. It is also called dinitrogen oxide because there are two nitrogen, that is what is called dinitrogen oxide. Now here first we will find out what is the valence electron, what is the total valency electron of this molecule. Now you know a nitrogen having 5 valence electrons and oxygen having 6 valence electrons. That is why there are 2 nitrogen, 5 and 2 and plus 6, that is equal to 16. That means 16 valency electrons of nitrous oxide present. Now it is also called dinitrogen oxide. And after that we will find which is the least electronegative. There are two atoms present here. One is nitrogen, other one is oxygen. But nitrogen 2 times, so because the formula is N2O. And that is why you can say these two nitrogen atom are least electronegative when compared to oxygen. That is why you should put in the center and outer side the oxygen. And this is the skeleton structure. What is that? The total number of valence electrons should be 16. And in middle of atom there should be one chemical bond formed. That means sharing of electrons should take place and one chemical bond should form. That is why first I put this pair of electron and this pair of electron in the middle of the atoms, and that is forming chemical bonding. And after that it is 2 plus 2 4, and here 2 6, 2 8, 2 10, 2 12, 14, 16. That means 16 electrons are presented by N2O, nitrous oxide. This is known as skeleton structure. In skeleton structure, what we will find? Whether 3 atoms are satisfied octet rule, whether they have 8 electrons or not. See, check here. This is surrounded by the red line. That means red line here, oxygen having how many electrons? 2 plus 2 plus 2 plus 2. That means here 8 electrons in this outer shell, and that means oxygen having 8 electrons. If it is octet, it follows octet rule. And this nitrogen also, the side nitrogen also, 2 plus 2, here 2 electron, here 2 electron, there are 4 into 2, that means 8 electrons surrounded by nitrogen, and that is also satisfy octet rule because 8 electrons is counted, so it is following octet rule. But this nitrogen, middle nitrogen, what happens here? Only this side 2 electron and this side 2 electrons. What is the number of electrons here? 4. That means here deficiency of octet rule. Here deficiency of 4 electron. That means here nitrogen, this middle nitrogen, not satisfied octet rule, not having any 8 electrons. That means here this is problem. Here not satisfied the octet. So again see, there are 3 atoms, 2 nitrogen, 1 oxygen, and this first nitrogen that is satisfied octet, and next middle nitrogen that is not satisfied octet, it is only 4 electron, and last oxygen will satisfy the 8. That means here this is the skeleton structure, where here it is that is covalent bond, this is also covalent bond. Then what is the possible Lewis structures? Because this is the skeleton structure, and what is the other possible structures? Now if I will transfer this electron, which electron? This electron to middle of this nitrogen oxygen, and also this pair of electron, that this electron, if we transfer this in middle of 2 nitrogen, then what is the result? See, this electron, pair of electron transfer to middle of 2 nitrogen, and this pair of electron also transport to middle of nitrogen and oxygen. Then what is the result? The result is in middle of nitrogen oxygen there are 2 pair of bonding electron. Now see, before that one, and now we are transferring, so it is 2 pair of bonding electron between this nitrogen oxygen. And similarly, if we transfer this pair of electron to middle of 2 nitrogen, also it forms 2 pair of bonding electron. That means here it forms 2 bonds. Here also it forms 2 bonds. That means 2 bonds between nitrogen and oxygen and 2 bonds between nitrogen and nitrogen. Now we can check whether it follows octet rule or not. Yes, we will check here. Now, whereas this nitrogen 2 to 4 to 6, 8. That means here it is 8 electrons. It is 8 electrons. And when you come to that oxygen, here you can also see 2 plus 2, here 4 and 4 plus 4, 8. That means here also it follows 8 octet. But middle nitrogen, what happens to middle nitrogen? Again check. 2 plus 2, 4, 2 plus 2, 4. That means 8 electrons here in middle nitrogen. That means it is the one of the structures, Lewis structures, but whether it is the final structure or any structures, that Lewis structure can be possible, we will check. Then we here that is in middle nitrogen middle 2 bonds, and here between nitrogen and oxygen 2 bonds, that is the Lewis structure 1. And other structures, if possible, we will try and we will write, and after that we will find which is the best Lewis structure by the help of formal charge. Now we will check the next Lewis structures. Now we will find the second Lewis Dash structure. First Lewis Dash structure, this one, where you can see the transfer of electron can take place from this nitrogen to this middle of 2 nitrogen. That means this pair of electron transferred to this place, again it forms a pair of bonding electron. Similarly, between nitrogen and oxygen, 1 electron pair can be transferred to this oxygen. See again, this pair of electron transferred to here between 2 nitrogen, and this pair of electron transferred to this oxygen, and here also it will form non-bonding electron. It forms bonding electron and it forms non-bonding electrons. Now this is the second structure you can find. Since a pair of electron transferred to here, that is why here 3 pair of bonding electron form. That means 3 bonds now it forms. Now since this pair of electron transferred to here, that is why it forms 1 pair non-bonding electron instead of 2 pair bonding electron. It only here 1 pair bonding electron. Now that means here in between 2 nitrogen, that here it will form 3 bonds, and between this nitrogen and oxygen it forms 1 bond, 1 chemical or that is covalent bond. Now here 3 bond between these 2 nitrogen, and here it forms 1 bond between nitrogen and oxygen. Again see, other Lewis structure is possible or not. Here you can say, since there are 3 pair of bonding electron, this is your second Lewis structure. Now you can do 1 pair of electron bonding electron transfer to this nitrogen, first nitrogen. Other bonding pair electron that also can here transfer to this nitrogen. That means this pair of bonding electron transfer to here acts as a bonding non-bonding electrons. Similarly, this pair of bonding electron transferred to nitrogen this place, and it acts as a non-bonding electron. Now second in oxygen you can see there are 6 non-bonding electron and non-bonding pair of electrons, and here 1 pair of bonding electron. So you can transfer this pair of bonding electron to here between nitrogen and oxygen and acts as bonding pair of bonding electron. Similarly, this pair of non-bonding electron of oxygen transferred to here between nitrogen and oxygen. Now it will act as bonding pair of bonding electrons. Now here third structure it is formed and by the transfer of electrons. Now see, since two pair of electron transferred here, that is why two pair non-bonding electron forms and one pair bonding electron. Since two non-bonding electron transfer to here between nitrogen and oxygen, between nitrogen and oxygen, that is why three pair bonding electron form, one bond between chemical bond between nitrogen and nitrogen and three bond between nitrogen oxygen. This is the structure of third. That means here how many structures are formed? Three structures are formed. First one you can say this, and second this, and third this. Now here we will find which is the best structure out of three Lewis structure, which is the best structure. Now you will find the formal chart for structure 1, structure 2 and structure 3. And after that we will say where the least value of oxygen, value of nitrogen oxygen is there, and that is the best structure. And also will observe the electronegativity value of oxygen, whether it is satisfied or not. Suppose oxygen will acquire positive charge as a formal charge, that means it is not a good structure because oxygen is the more electronegative than nitrogen. That is why we should occupy -1 or 0, but oxygen only acquires -1, not 0. So we will check structure 1. In structure 1, the green surrounding, that is called bonding electron, and simple, that is non-bonding electrons. Now suppose this nitrogen is 1, this nitrogen is 2, then we will calculate formal charge of nitrogen 1, nitrogen 2 and oxygen. Now for structure 1, formal charge of nitrogen, you know valence, what is the formula? Valence electron minus non-bonding electron minus bonding electrons divided by 2. Now see, nitrogen valence electron 5. The non-bonding electron, see here, these two pair, that is non-bonding electron, that means 4. And these two pair, that is bonding electron, that is why 4 by 2, and result is -1. Now nitrogen, second nitrogen, valence electron 5, and here there is no non-bonding electron, 0, and minus how many bonding electron? This side 4, this side 4, so 8 by 2, and result is +1. Now formal charge of oxygen. Now in oxygen, what is the valence electron? 6. And what is the non-bonding electron? This 2 and 2, 4. And what is bonding electron? 2 plus 2, 4. So 4 by 2, and that is equal to 0. Now important thing you can see here, oxygen, though it is more electronegative than nitrogen, but it acquires 0, which is the not possible at all, which is the not, you can not regard as the best structure. It should be, it is not a good structure because the oxygen, that is value is 0. And so this value is 0, and it is called that is minor one. It is not a good structure, it is very minor structure. This now you regard as the minor structure. Again you will compare structure 2 and structure 3. We will come to structure 2, then we will come to structure 3. Then we will compare 3 and we will find the best structure and also resonance structure. Now again see, there are 2 plus 2, 4 bonding electron for nitrogen, 2 plus 2, 4, 2 plus 2, 4, 8 bonding electron for this nitrogen, and here this is 4 bonding electron for this oxygen. I hope it is clear. Any doubt? Next, come to second structure. In second structure, second structure, this is the second structure. In second structure, how many bonding electron for this nitrogen? 3 pair. And how many bonding electron for this nitrogen? 4 pair. And how many non-bonding electron for this nitrogen? 1, 2. And for this nitrogen 0. and this oxygen 6. Now we will calculate formal charge of nitrogen 1. What is the valence electron? 5. Then non-bonding electron 2. This is the non-bonding electron. And after that here, and how many 6, that is bonding electron, because 3 pair nitrogen, 6 by 2, the value comes to 0. And next is here for this nitrogen, valency electron 5, and there is no non-bonding electron, that is why value is 0. And here what is the bonding electron? 8, because 4 pairs are there. 1, 2, 3, 4 pairs are there. That is why should be 8 by 2. It should be 8 by 2. That means the value comes to +1. And next come to here formal charge of oxygen. What is the valence electron? 6. And how many non-bonding electron? 6. How many bonding electron? 2. So 6 minus 6 minus 2 by 2, that is equal to -1. Now you can see here the oxygen satisfied the formal charge because it is -1. It is the more electronegative than your nitrogen, so also it acquires negative charge. And Fc, the lowest value, you calculate the lowest value that comes to 0. And Fc of oxygen, that is -1. So it may be the best structure. Again we will compare that is third structure, and after that we can say which is the best structure, which is the minor structure, and which is very minor structure. Now only 2 structure you have calculated till now. You will calculate now third structure. Now see this third structure. This is one pair of bonding electron here between 2 nitrogen, and between nitrogen oxygen 3 pair of bonding electrons, except these all are called as non-bonding electron. Now we will calculate formal charge for third structure. Now here it is the third Lewis structure of nitrous oxide. Already I have explained for structure 1 and structure 2. Now the structure 3. In structure 3, here one pair of the electron, that is bonding electrons between these 2 nitrogen, and 3 bonding electron between nitrogen and oxygen. Then it is easy to calculate formal charge of nitrogen 1, nitrogen 2 and oxygen. Nitrogen 1, you know valency electron 5 minus non-bonding electron C, 2 to 4 to 6 non-bonding electron 6, and bonding electron only 2. So 5 minus 6 minus 2 by 2, and that is equal to -2. And similarly formal charge nitrogen 2, that is valency electron 5 minus, there is no non-bonding electron here, so 0. And here how many bonding electron? Here 3 pair, 1 4 pair, that means 8 bonding electrons, so 8 by 2, that is equal to +1. 5 minus 0 minus 8 by 2, that is +1. Next come to oxygen. Formal charge of oxygen, valence electron 6, non-bonding electron 2, and bonding electron 3 pair, that is 6 by 2. And what is the answer? +1. See, very important thing here. Oxygen is more electronegative than nitrogen, but oxygen acquires a positive charge here. But nitrogen 1, that acquires a -2 charge. That means negative value here for nitrogen 1, but positive value for oxygen. So it is not a good structure, Lewis structure. That means it is not a good Lewis structure. It is very minor value because here nitrogen whose value is -2 and oxygen whose value is +1. So I hope it is very minor value, but we will compare structure 1, structure 2 and structure 3. Now, so when you compare structure 1, structure 2 and structure 3, we find structure 2 is the best one. Then what is the structure 2? Remember, nitrogen, 3 bonding, 3 chemical bonding, nitrogen, 1 chemical bonding, and so this is the best structure. Here 2 electron pair we should write. So here it should be the best structure. Now you can compare also. This is 8 octet, this is 8 octet, this is 8 octet. Here generally structure 1, structure 2, structure 3 all are having 8. That means following octet rule. But important, the value, Fc value is not satisfied by 1 and this is 1 and 3 here, but here I have mentioned in different way, and here I have written that resonance structure. Resonance structure, since I told here 3, actually this is the 3, and here we find this is very minor value, and this is the 2, which is the best one, because here the value formal charge, that is very least value. And now the last one, that is here minor. That means here very minor, and this is minor, and this is the best one. So, and it indicates the resonance structure. Here in red line, in red surrounding us, you can find what are the formal charge. Formal charge is -2, +1, +1. And here it is 0, +1, -1, which is the best structure, and here -1, +1, 0, because oxygen should not have negative, should not have 0 value in compared to nitrogen. It should be more than negative value than nitrogen. And here oxygen acquires negative charge, that is very good in compared to nitrogen. And here it is -2, nitrogen is -2, whereas oxygen +1, that is very minor value. So this is the resonance structure, but when I explain, this is, I think this is the structure 3. This is the structure 3, and this is the structure 2, and this is the structure 1. This is the structure 1. So this is the resonance structure of nitrous oxide, and these are the Lewis structures according to formal charge, which is the best. Second one is the best according to my explanation. This is the best. So this is the third structure, this is the second structure, this is the structure 1, and this is the resonance structure of nitrous oxide. And thanks for my watching video. Hope you will subscribe my channel B.L DASH Short and Sweet in Chemistry.